Hello, my name is Jacob Boatwright, and this is an FE problem for CEE300 Engineering Business Practices. To start off, we have the problem statement. It reads, you put $750,000 into a savings account. They give you a nominal interest rate of 5.73% compounded continuously. Over the next 5 years, there's an inflation rate of 2.15%. And the question is asking how much spending power does the money in your savings account have after the 5 years? To start off with this problem, it's important to understand the different givens that are here. So we have our givens of the nominal interest rate is 5.73%. The inflation rate is 2.15%. The time for the period is 5 years. Your initial invested is $750,000, and you're solving for the spending power after the time of 5 years. To start off with this problem, it's important to understand which interest rates you need to be using. And we need to, the process is going to be to convert our nominal interest rate into a real interest rate. Now this requires two different steps to get there. The first step is we have to convert the nominal interest rate into an effective interest rate. There are two different equations that can be used to solve for the effective interest rate. The one that we want to use is the one that's for continuously compounded, just as it said in the problem statement. I'm going to go ahead and write both equations so that you have them and know that there's different ones. So the first one that we won't be using is the effective interest rate equals 1 plus the nominal interest rate over the compounding period, raised to the compounding period minus 1. So this equation we aren't going to use. We're going to use the other one, which is the effective interest rate equals e to the nominal interest rate minus 1. And then from this, we have the nominal interest rate. We're just going to plug that into the equation to get the effective interest rate. One thing to make sure of is that when you convert your percentages into, or put them into the equation, that you need to convert them into a decimal form. So for the effective interest rate, it equals e to the 0.0573 minus 1. And that equals 0.0590, or it's 5.90%. Now that you have the effective rate, the next is to convert that effective rate into a real interest rate. So you have your effective rate of 5.90%. And the equation that you're going to use to get your real interest rate is the real interest rate equals 1 plus the effective interest rate over 1 plus your inflation rate minus 1. So from this equation, we have all the variables that we need to solve for the real interest rate. So that's going to equal 1 plus 0.0590 all over 1 plus 0.0215 minus 1. And using your calculator, you get that to equal 0.0367, or that's going to equal 3.67%. So that's your real interest rate. And when we have the real interest rate, we can now move on to find the spending power, which is our original question. For a continuously compounded rate or inflation rate, and interest rate, we need to use the equation of P equals A E R T. And in here, we have the A, we have the T given in our givens, and the R is actually our real interest rate, equals R, and that equals the 3.67%. So from here, to solve for our spending power of P, we just, again, plug and chug the givens from the equation. The hardest part about this equation is converting from your nominal interest rate into a real interest rate. But so we have P equals 750,000 times E 0.0367 times 5. Sorry, got ahead of myself. And then just plug and chug from there, and your spending power after the 5 years is $901,061.